Hey, what's up everybody? We're here to talk about the third method for solving a system of equations. Today we're going to be talking about elimination method. I do want to let you know uphand that this is going to be a two-part session of notes. In this video, we're going to talk about basic and intro elimination method. In another video, I will talk about a little more advanced involving multiplication and addition, or multiplication elimination method. My apologies. So first and foremost, what is elimination method? Well, of course, it's another method for solving systems of equations. And we do this by adding or subtracting to eliminate variable. So what this is really going to look like is we're going to have two equations. And we're basically going to try and add them together, or we're going to subtract them in order to make two variables cancel out when they have the same coefficient. So let's look at the steps to solve. First of all, we have to make sure that the equations are lined up. We need to have x's over the x's, y's over the y's, and a constant over a constant. If they're not lined up, this is not going to work. Second, and obviously our new step, we're going to have to add or subtract. We're going to have to add or subtract these equations to eliminate the variable with the common coefficient. Don't forget what coefficient means. This is actually one of our key vocab words from last semester. A coefficient, of course, if you remember, is a number in front of a variable. Now that sounds simple enough, but it's a description of the variable. If I say like 5x, the coefficient is 5 because that's telling me how many x's I have. We're looking for the numbers in front of the variables. Step 3. What we're going to have to do then, whenever we add or subtract equations to eliminate a variable, we're going to be left with a simple statement where we only have one variable left. And we are going to solve for that remaining variable. Now, we've already solved equations before. This is your callback to semester 1. Step 4, what we're going to have to do then, once we know what this one variable is, we're going to have to actually substitute our answer into either original equation and solve for the other. Substitute your answer into either original equation and solve for the other variable. So what does that look like? Well, we're going to jump into it right now. I'm going to go ahead and move this up, so hopefully you have that down. Or if you're just following along, that's OK. We're going to look at number 1, of course. Let's look at this first. I'm going to change out my colors because I like my colors. I have two equations, y equals 3x plus 4, and y equals x minus 2. Now I need to solve this by elimination, and remember that I want to see which equation or which variables have the same coefficient. Now looking at this, I can say that the y's have the same coefficient. In the top I have a 3x, and in the bottom I have a 1x. But in both equations I have just one y, and hopefully you remember that. Whenever we have no number out front, it's just a 1. So since these are the same, we want to cancel these out. Notice that these are both positive. Since they're both positive and we want them to cancel out, we're actually going to subtract the bottom equation from the top. So I'm going to subtract this, and I'm going to do 1y minus 1y. That's going to leave me a 0, because those totally cancel out. Then I have 3x minus x. That's going to give me a 2x. And then I'm going to have 4 minus negative 2. We have to be careful with that. 4 minus negative 2 is going to give me a positive 6. Don't forget that minus a negative makes a positive. So now we have this equation, 0 is equal to 2x plus 6. It's totally possible to have this. Don't forget. Now we want to solve for x, right? This is step 3, solve for the remaining variable. We no longer have y's, we just have x left. At this time, we need to get x by itself. So we have to get rid of that 2, and we have to get rid of that 6. Remember that we want to get rid of the 6 first, because it is the constant. And so what I'm going to end up with is I'm going to go ahead and bring my work up here. So I'm running out of room. We're going to have to subtract 6 from both sides. So these cancel out. And negative 6 is equal to 2x. Now again, I want to get x by itself, so I have to get rid of that 2. Remember that this is multiplication here, so it's like having a little dot right in there. And so to undo that, I need to divide. So I'm going to divide both sides by 2. And when I do that, I find that x is equal to negative 3. Negative 6 divided by 2 is negative 3. But don't forget, we're not done yet, because we need to do step 4. We need to substitute this answer into either original from the top. Now this is important because we need to know what y is. Remember that our solution to these equations is going to look like a coordinate point, x comma y. So I could plug x equals negative 3 into either of these top equations. I want to plug it into the bottom equation, however, because there's no coefficient in front of it. This can be tricky sometimes. Just understand the reason that I'm doing this is because up here's a 3, and that's going to make this number bigger. But down here I have just a 1, and that means that my y is just going to be equal to 1 times negative 3 minus 2. And that's actually simpler than trying to do 3 times negative 3 plus 4. It's a smaller number, it's nicer, it's easier for us to deal with. Because 1 times negative 3 is just negative 3. And negative 3 minus 2 is negative 5. So the solution for our first one, remember that we have to put this in x comma y, is negative 3 comma negative 5. Perfect. Now if we look at number 2, we're going to try to do the same set of steps. All right, make sure you're following those steps to solve. Those can be very helpful. And the more you do this, the more likely you are to memorize these. As I look at this, I want to make sure first and foremost that these equations are lined up. And I can see that they are because I see an x over an x, I see a y over a y, and I see a 13 over a 3. Those are the constants. So now I need to think which variables have the same coefficient. If I look at the y's, I see there's a 4 here, but a 1 here. Well, those aren't the same. Now, if I look at the x's, however, look at that. This x has a 1, this x has a 1. So I know that I'm going to want to get rid of the x's. So looking at this, since they're both positive, the x's, of course, I want to cancel out the x's. That's the goal. Cancel out the x's. So to do that, I'm going to have to subtract these, because what I want these x's to go to 0. So 1x minus x is going to be 0. Now I have 4y minus a negative y. Careful with that. Remember, 4 minus a negative 1, that's going to give me a plus 5. Because this becomes 4 plus 1. Don't forget the y. And this is equal to 13 minus 3, which is 10. Now this 0, because this was a 0x, is really just going to go away. And really my equation all comes down to 5y equals 10. So to get y by itself, I now just have to divide. I'm going to divide both sides by 5. So y is equal to 10 divided by 5. 10 divided by 5 is 2. Now I know you knew that already. Now we're not done yet because we still need to know what our x is. So to do this, we're going to end up plugging this back into one of those two equations. Allow me to make the suggestion. You try to want to, as I suggested in the previous example, you want to try to look for whichever equation is going to be simpler to deal with. Now when I look at this bottom equation, again I'm looking at this, if we look at this, you see that this y has no coefficient on it. That actually makes things a lot simpler because 1 times anything is that number. So if I go to do this, I'm going to find that this is x minus, since y equals 2, I plug that 2 in, x minus 2 equals 3. And now solving for x is as simple as it gets. I don't have to worry about any extra multiplication. It just goes that way. 3 plus 2, 5. So my solution, my coordinate, is 5, 2. Don't forget that these coordinates need to be in x, y form. Our 2 was the y. Y was 2. It was the first thing that we found, but that needs to be the second coordinate. Okay? Looking on down now at number 3, we're going to do the same set of steps. Let's try to do it even faster this time, though. Remember that we want these to be lined up, and if I look at that, they are lined up. Now we look for the variable the variables that have the same coefficients. And I see that in this case, it's going to be the x's. All right? And since both x's are positive, we're going to subtract. We need to subtract these because we want the x's to cancel. 3x minus 3x is going to be a 0. I've got a negative 10y minus a negative y, and that will become negative 10y plus 9y, which is just a negative y. And this is equal to 14 minus 15. 14 minus 15 is negative 1, at which time we get that negative y is equal to negative 1 because the 0 just goes away. Remember that we want a positive y. We don't want this negative. We need to get rid of the negative. So to do that, we're going to divide by negative 1. In doing so, we get that y is just 1. Now don't forget, we still need to plug this back in to figure out what x is. We need to know what our x is. So you could actually plug this into either problem. It really doesn't matter. I'm going to go ahead and do the top one just for simplicity's sake. 3x minus 10 times y, remember that y is 1, equals 14. So if I do this, 3x minus 10 times 1 is just 10, equals 14. Now I can show you that we're going to add 10 to both sides so that 3x equals 24, because 14 plus 10 equals 24. These 10's canceled. And to get x by itself, I'm just going to divide by 3. 3's cancel on the left side. X equals positive 8. Now remember, last step, write your solution as a coordinate point. And the coordinate point is 8, 1. Okay. 4 and 5, 4 is actually very similar to this. So we're going to skip this one in this video. If you feel tempted to try 4, there it is. You can pause and try it out. Your solution should be negative 2, 7. I'm going to go ahead and flip over to the next page. And we are going to continue on. An extra problem, number 5, very similar to what we were doing on the previous page, only there's a slight change. In this particular case, they're lined up. I've got an x over an x, I've got a y over y, and I've got a constant over a constant. But this time, I notice that the x's have the same coefficient, but different signs. Notice that one is positive, the other is negative. When this is the case, this is where we are going to add the equations together. And we want to add because this positive and this negative are going to cancel out. So, if I may, I'm just going to add these two equations together. 4x plus negative 4x is going to cancel out. That's going to give me 0x. 9y plus 7y is going to be 16y, just like this. And this is equal to 5 plus 11, which is 16. So when the 0 goes away, we now know that 16y is equal to 16. And if I divide both sides by 16, I find that y is equal to 1. Now this we're going to have to plug into one of these equations. For simplicity's sake, I'll go do the top. And it's actually very lucky that we do the top, because had we do the other one, we'd have to get rid of that negative 4. But nonetheless, it's something that we could take care of. Remember that y is now 1, so I plug that in. And our equation reads as 4x plus 9 equals 5. Okay, hopefully you know that 9 times 1 is just going to be 9. I want to get the x by itself. So to do that, once again, I'm going to get rid of the 9 first, because that's the constant. And 4x is equal to a negative 4. Finally, I divide by 4 and find that x is equal to negative 1. And so the solution to my equation is, the solution to my system of equations is negative 1, comma, positive 1. All right. Now we're going to skip 6 and 7 because these follow similarly to number 5. I feel like you could do that easily. As I look down at number 8, the first step is violated, essentially. When I look at this, I can tell that they're not lined up. So we want to be able to line this up so that I have an x over an x, a y over a y, and a constant over a constant. So in order to do this, I'm going to have to move one variable to another side. Now for this, I think I want to start with the top, and I want to move this 3y over. So that way, I will have the x's and the y's on the left side of the equation and the constants on the right. So remember that to move a variable from one side of an equation to the other, I just have to do the opposite operation. So I'm going to subtract 3y from both sides. So now this top equation will be x minus 3y equals 11, because now this 3y is canceled out with that 3y we had above it. Now the bottom equation still reads 2x minus 3y equals 16. Hopefully you're starting to see a pattern. Whenever we have the same sign, we're actually going to subtract equations. And when the signs are different, we're going to add. Now what do I mean by that? Notice that the y's have the same coefficient, and each coefficient has the same sign. They're negative 3's. That's what I mean by same sign. They both have negatives. Now because they're both negatives, that's where we're going to subtract. And we're going to subtract that whole, we're going to subtract these two. So x minus 2x is actually going to give me a negative x. A negative 3y minus a negative 3y. That minus negative is going to become a plus, and this is negative 3y plus 3y, which will become 0. So I have plus 0, and this is equal to 11 minus 16. 11 minus 16 is negative 5. So in its simple form, negative x equals negative 5. And since we want x to be by itself, we have to get rid of the negative. I would be better off saying we want x to be positive. Whenever we have this negative out front, we want to get rid of it by dividing by the negative 1. And we find that x is equal to positive 5. Now, of course, we're not done. We know that our x-coordinate here is going to be 5, but we need to know what the y is. So we're going to go ahead, plug this in into one of our equations to see what we get out. And I'm going to take this x equals 5, and I'm going to plug it into this here. So if x equals 5, we're going to have 5 minus 3y equals 11. Now, once again, we're trying to get the we're trying to get the y all by itself. So I'm going to subtract 5 from both sides, and I get negative 3y equals 6. 11 minus 5 is 6. And finally, to get y by itself completely, I divide both sides by negative 3. So y is equal to 6 divided by negative 3. That's negative 2. The solution to my system of equations here is 5, negative 2. Last but not least, I wanted to do number 10. Number 9 is very much like number 8. You just have to move one variable to the other side. In this case, I'd recommend moving the 2x over so that you have the 2x and the y on one side instead of moving the 4y over. If we look at number 10, you see how weird this is. This is actually weird in and of itself because I have x's with the same coefficient, and then I have y's with the same coefficient. And they all have the same sign. So because, once again, these all have the same sign, 3 and 3 are both positive, 4 and 4 are both negative, I'm going to subtract. Same sign means subtract. So 3x minus 3x is going to be 0. And then we have a negative 4y minus a negative 4y. That becomes a 0. I'm going to put plus. And then we have negative 10 minus negative 13. So that's going to be negative 10 plus 13, which is 3. And so 0 plus 0 is just 0. 0 equals 3. And really the question is, does 0 equal 3? No, it doesn't. We all know this. It doesn't. So here we have no solution. These lines are actually going to be parallel and going in the same direction. No solution for number 10. that'll be it for this video. Try out number 11. You can feel free to try to do the others. Whatever you get, your answer to 11 should come out to be infinity. So if you want to check your answer with that, it should be infinity. Until next time, when we talk about multiplication with the elimination method, I hope you guys have a great day. We'll see you later.